Hi, in this new chapter P3, we have the opportunity to revisit again the multiplexer of 8 channels, the MUX8, the MUX8, using now a hierarchical approach, what we call the Plan C2. And that is going to be here since now and for all other projects. So this is a classic example where you can see the dynamics of this idea of using building blocks to think about your circuit. So you have an entity to design. That entity is, as usual, and you know well now, the MUX8. And this time we will try to invent it. You know, this is what we have in mind always, because it's a project, right? So we will like to invent it, you know. Let's imagine an internal architecture, but this time not based on equations or just trying to copy the truth table as we have done before, but just using similar components of the same kind. For example, as you see in this diagram, you know, the chip 2 is MUX4, or the chip 3 is just a MUX2. You see, if you have to invent a MUX8, why not to use MUX2s, which is the same device? It's going to be the similar table, similar to table. So why don't we use smaller components of the same kind to build larger components? In this way, for example, if we have in mind a MUX32, a multiplexer or data selector of 32 channels, why not to invent it based on MUX8? So this device now, that is the objective of the project, maybe later on a component. That's the idea. Later on it may be a component just for building a chip of the same kind but larger. With in this case, this larger, you know, means more channel capability to switch, okay, to the output. So that's the idea now. So this time we come back to the circuit MUX8, okay? Again, to the circuit MUX8 that has this symbol and this table. And now what we have in mind is building it again using a different approach, a hierarchical approach, you know, based on the idea of using components. And this is, you know, similar circuits of the same kind. For example, MUX2 or MUX4. And that's the idea now. So let's see if we can invent a planning, you know, a schematic where you are going to have several layers, and in different layers, different components and different connections. Components and signals, that's the idea, okay? So this is a typical circuit where this idea is very well understood, I guess. And so, you know, that's the point. As usual, we like to invent the architecture to place inside our entity. That is what we have in mind, okay? So, how to start? How to start thinking about this in this new way? Well, logically, the best idea is to go and watch this again, the truth table, okay? This time not for converting it into VHDL as we did in the plan B, you know, or as by means of a flowchart, not like this. Or not because we like to find an equation or getting all the ones or all the zeros, all the products and sums to have something to write as an equation in VHDL. Not this time like this, but with the idea of visualizing. Let's see if we are able to watch in the table, you know, the same idea of a multiplexer, because if this is a multiplexer of 8 channel, probably it is easy to see multiplexers of 2 channels, okay? For example, if you keep an eye on this table, you know that there is up there the disable section, that's right, but down there is the multiplexer section, and here is where you are going, you are changing the channel depending on the binary code. So you see, if you are selecting, for example, if you are thinking on the S0, the S is the the selector, you know, depending on the binary code that you are applying here, you are selecting one channel or another. So if you think only, not on the 3 wires, but only on S0, what is what you see? 0, 1, 0, 1, 0, 1, you know, exactly a repeated a pattern that repeats all the time like that. So what you can do here? So it is a good idea to section the table like this, considering this 0 and 1, and this 0 and 1, and this 0 and 1, and this 0 and 1. So if you section the table like this, you know, every 2 rows, and the rows associated to the value of the S0, what is here is a kind of a MUX2, you see. This is a kind of a MUX2, because you take the channel 0, or instead you take the channel 1, but this idea is repeated down there. You copy the channel 2 or you copy the channel 3, and again and again. So you can imagine that here you may have 4 MUX2 devices, and you know the MUX2 is something like this. Is a select input, only one wire. You have the channel 0, the channel 1, and the Y, and the enable active low. The same as this circuit here, but you know, smaller. So this is a MUX2, a multiplexer of 2 channels. So this device, for example, may be used to implement, that's the idea, to implement as a circuit the 2 lines of these 2 lines of the 2 table. Then another one like this, the next 2, and so on. Okay? So that's right. Perhaps 4 multiplexer of 2 channels can be used to organize this MUX8. And then what? Well, that may be a faster stage, so let's draw it. You may consider a circuit like this. One section, 2 section, another section, and the last section, the 4th. So what? You may like to generate the Y, the Y, the Y, and the Y. This is channel 0, channel 1, channel 0, channel 1, channel 0, channel 1, channel 0, channel 1. You see, you are using, and this is S, 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 and S, and the enable active law, enable active law, enable active law, enable active law. So you have a MUX2, another one, MUX2, another one, MUX2, and another one. That's an idea here, okay? So you see, you are using the S0 to select. So why don't we attach them all together like this? And let it be like that. And this is the S0. So the S0 is for selecting channels. And which channels? Those ones. You see? That one, and that one, that one, and the next. The 8 of them. So you see the table? The first MUX takes the channel 0 and the channel 1. So this may be the first MUX. You can call it chip 1. This is the chip 2, the chip 3, and the chip 4. And this is the channel 0 port, channel 1 port, channel 2, channel 3, channel 4, channel 5, channel 6, and the channel 7 of the data. You know, you can do that. And then there is something that you don't know yet where to connect it to, the enable active law. And here is the Y, naturally. And if you like, let's use this tactical thing of using both a buffer and an inverter, okay? So let's use a buffer and an inverter for generating the Y and the Y naught as outputs of our MUX8 device. So you see, just inspecting the table, you can realize this circuit. And then what? Well, just pay a little bit of attention again, because now what is left, you see, what is what you want exactly? You like to select the channel 0 or the channel 2 or the channel 4 or the channel 6. If S is 0, you see when S0 is 0, you like to select the channel 0, the 2, the 4 or the 6, the even ones. And in which way? Well, with another multiplexer, but this time you have four data to select here. This wire, this wire, this wire, or that wire. So you can name them now. For example, let's name, I don't know, key 0, key 1, key 2, and key 3. Why not? So now you have 4 wires to select, and the wires corresponds to channel 0, channel 1, or channel 2, channel 3, you see? So in which way? Well, select again. You see the idea? You like to select the channel 0 or the channel 2 or the channel 3. So this is again another MUX, another data selector, wire selector. But this time, you see, because you have 4 wires, you can imagine the truth table, because now you see you have 2 wires left here for selecting. So why don't you take them like this, you see? 0, 1, 2, and 3, right? So you see when 0, when 1, when 2, when 3, you select the output of one of these MUX2s that you have in this previous stage of the circuit. So clearly this is because you like to use here as this way a circuit that is going to be 2 wires for selecting. This is S, well, yeah, 2 wires now. This is S, 1 down to 0. This is the channel 3, the channel 2, the channel 1, and the channel 0 of this device, and the enable active law, and this is the Y. So, well, I guess that you have understood now. The connections are very clear. The key 0 wire goes straight to the channel 0. The key 1 to the channel 1, the key 2 to the channel 2, and the key 3, the output of this chip 4, goes to the channel 3 of this new device, a new chip, a new component, you see? So this is the chip 5. So that's it in some way, and this is, you know, the same color because it's the output, so you can use this output and you can name it as usual, Q, right? You can give it a name. Well, let's use the same ink. This is black ink, so the Q is going to be black ink. So that's it. You have the ports. Ah, well, something is left. Well, but you have guessed it. You see the selection of this chip 5 MUX4. Okay, this is a MUX4. This MUX4 naturally has to go to the input, and you can now modify the boundary of this device, make it that practical, and now you can do that connection very easy. You see, you have 2 more wires to connect here, so this is 2 wires, so this is S2 down to 1. So you've got it, 3 wires for selecting, because you have 8 channels connected in this specific way, because this is what you want. The 2 more significant wires are for selecting the key 0, key 1, key 2, key 3 wires. Okay, and the other one, the less significant selector bit S0, is for selecting in this previous stage between 2 channels. So that's a possible situation. Ah, well, right. There is the general enable. How can you do that? Well, so I guess that's a good situation here. You can do it as you like, but for example, you can connect all the time these to 0, these to 0, the enable connected all the time to 0 in this initial stage, and then you can connect, if you like, the input port enable active law straight to the enable active law, you see that way, of the chip 5, because in this way, if the enable active law, the general one, the one in the truth table, is 1, this device is going to be blocked because it has a similar table like this. Absolutely. So this is perhaps the final circuit. And okay, and it may work as a multiplexer. If you are not sure what goes next, you see in paper, if you are inventing something like this, at least now in paper, later you will try it for real using the simulator tool or in the prototype board, but now in this way, in paper, using paper, you know the way we go through this. For example, we use another color for inputting some vector, I don't know. Let's imagine that we are going to apply 110 in the selector channel. So what is going to happen? If this is 1, 1, and 0, you see, the 0 in the S0 is going to make it possible to select at the same time in this initial stage the channel 0. So here you have the channel 0, here the key 1 becomes the channel 2, the key 2 becomes now the value, the data in the channel 4. So these 4 channels has gone through this first stage like this, and this is the channel 6. But then what goes next is you clicking 1 in the other. Well, it's your input, right? 110, as you see in the table. But now this 1 goes straight to this second circuit here, the chip number 5. And what happens? 1 is a 3. So what you are selecting is the channel 3. So in the end, the channel 6 is the one that goes to the output. And this is the channel 6 data not. So this is what you want. Exactly. If you are applying the 6, this means that you like to do that selection. The channel 6 goes to the output. This is what you want, applying a 6 here. And channel 6 not. Exactly. When, you know, this happens when this is a 0. And if this is a 0, you have a 0 here, so the device is enabled and everything goes fine. So that's the way to try to see if what you had in mind and now that becomes a schematic in a paper works, at least for some values. Then you better go, as I say, and do a proper simulation of all the convenient channels and the more common combinations to see if the full chip works as expected. But that's the end of the planning now. And what is what you see here? Choose sections and a lot of chips, you see, for implementing the same table that was solved in plan A using a single equation. But doesn't matter now. The idea is not finding the best circuit, but finding another circuit, which in this case is based on this new plan 2. You see, the idea of organizing a circuit like this. This is the top entity, the one that you have in mind, the MUX8. This is the top entity. So this is the MUX8.bhd file, the top entity, right? And then what? Inside you have the MUX2.bhd and the MUX4.bhd. So how, the next question here when you are inventing such circuits is, how many VHDL files are you going to use? Because you know there is not only one file here anymore. In Plan C2, because you are taking with you some components and logic gates, and who knows what is in your paper now, so you are taking with you more than one file. So how many? Well, I guess that you are inventing here, that you have to invent the MUX8 BHD, that's naturally the top project, And then you have to take with you another file, the MUX4, because the MUX4 VHD is a component of the circuit. And then there is another circuit that is used more than once. You know, the MUX2 is another component, and it is used several times. As the chip 1, the chip 2, the chip 3, and the chip 4, all of them are of the same kind, MUX2. So, right, that's the idea. Your project now has to be multiple file. This is the idea of a multiple file project. Okay, so in order to invent this circuit, you have to be aware of getting, first of all the components in VHDL, and finally organizing the top. And how to do that? Well, that's the next step. And let's stop the explanation here, because this next step is already solved in another video where you are, you know, acquiring or transforming a schema. You see these multiple, this plan C2 in VHDL. So that's the next, before, you know, going to the development section, you have to do that job, which is absolutely essential. You know, the MUX4 has to be yours. You have to have it. The MUX2 the same. You have to have it from other projects, whatever they are designed. Okay? And besides, think that the MUX4 may be organized as well internally using the same idea of the plan C2, using components like MUX2. So in the end, you have MUX2s in this top entity and MUX4, but perhaps you also have that internally, the MUX4, when you go to Control C, to the child sheet of this chip 5, if you go inside this chip, perhaps you may have inside another similar plan where the MUX4 is invented using MUX2 and whatever else. So you see, first of all, find the components, name all the connections. You see, I usually use different colors to do that job. You see, the ports has a color, and then the internal signals, you see, this is a signal. This is very important. Every signal has to have a name. So do that job, and then leave the gates as they are to annotate them in the VHDL. But then there is the crucial question that I leave it for you, so that you can think about it and you can watch the video. But you have the advantage that it's going to be all the time the same way. So the question now is how to translate such architecture, okay, such circuit, such, you know, hierarchical circuit, such architecture into VHDL. You know, how to translate, you know, the one that is the MUX8, right? The MUX8 VHD. So how to do that file, how to write it. So this is what you will find in a video, all right? And the point is that simple. Once you have learned how to do it, for example, inventing in this chapter 3, which is basically about arithmetic circuits, you will very soon be inventing, for example, a 4-bit adder based on 1-bit adders. So the same idea here. You see, you have a MUX8 based on MUX2s. So the same idea. So there you have something to copy and adapt as usual. So you will find an example, for example, the other 4-bit that you can use to do the same for inventing your MUX8. Besides, this MUX8 is as well a tutorial on the Digsys web, so you will find the exact translation of a similar circuit like this. So now I recommend you to try, because if you have problems in doing this step, you see, this is the fundamental step before getting them all and before going to the synthesis process, now the developing and testing naturally. Okay, this and finally, well, you have guessed that because we are inventing the same MUX8 as usual, you can carry on with you, you can take with you the test bench that you invented, for example, for the plan B1. So if you already have the test bench, you can take it with you into this new folder, okay? That maybe, for example, if you are thinking on developing this as an exercise, maybe LCSD P3, because this is the idea of hierarchical, and now you may say MOOCs 8, and here is where you are going to place the files, those files, and whatever else you like, the pictures and the scanned documents that you have available, or whatever you have, the data sheets. So you see the idea here, okay? So you can go to the development section when you have solved naturally this idea of how to translate such picture that has several signals and several components, every one with its own chip reference, you see, and the kind of component that it is, you know, everything is annotated perfectly well. So in this case you can go and translate that into VHDL and do it, as I say, in the same way as usual. So once, the point is that when you do that 1 or 2 times, it's going to be forever. It is the same way. So again, translating this picture has no value. You do not get specific marks for doing that because it's kind of an automation, as I said before, for other plans, you know. This time is, again, fortunately, whatever you are inventing here, like this, translating it to VHDL is going to be solved as an automation. You see, it's very simple. Take something to copy and adapt it to be like that, as you can see in the video recorded on digsys. Okay.